another root. Now, you could double distribute this x plus 4 times x minus 3. If I double distribute, I get x squared minus 3x plus 4x minus 12. And I get x squared plus x minus 12. So I could say that this is also an equation for this quadratic. This is the standard form for this guy, and this is the factored form for this picture. Now, why do I not need to do this extra work? Because it just said write an equation, so this will do it. Don't do more work than you need to. Although, remember, math is all about what? Are you allowed to do it or not? And yes, I could double distribute, combine like terms here, and simplify this to be y equals x squared plus x minus 12. Just because I'm allowed to do it doesn't mean I have to do it. I could leave it just like this. All right, so now you know factored form of a quadratic, and that one is done. All right, we're going to go on to our last one. Our last one is the, just trying to get it up over here. All right, last one is the vertex form of a quadratic. Now, vertex form. So we have factored form, this is vertex form. Vertex form is, like I've said before, our max or our min. That depends whether it opens up or opens down. Let me just take this here. All right, so this one's going to look a little different. F of x equals a, that's our GCF or our leading term, times x minus h squared plus k. Now this one's the most different. This is the most probably new for you. So let me just explain to it. The next lesson, which we do I think on Thursday, is we're going to show you how to put it in this form, quickly doing some tricks. All right, HK are numbers. They're real numbers. Now, this is important. HK is the vertex. That is the turning point, max min. And x equals h is the axis of symmetry. Which you guys already know that if you have a quadratic and you have this minimum point here, and it opens up, that this is your vertex, right? You guys already know that. So you know that whatever this point is, whatever this xy point is, the axis of symmetry is the vertical line that will cut that in half. So the equation of this line is x equals whatever this value of x is. So here, if HK is the vertex, then x equals that number is the axis of symmetry. All right, let's go through a few examples. All right, if A is 1 and the vertex is 5, 4, write the equation of the quadratic function in vertex form. Now I can say write the equation in vertex form because there's only one way to do this. So we're going to write it like this. We're going to have f of x or y, I guess we could use, doesn't matter. Let's go with y. Y equals 1, that's my value of A. X minus 5 squared plus 4. And we're done. Now, just to give you a visual, 5, 4 is over here somewhere. So it's a parabola that kind of just looks like this. And it opens up because the value of A is positive. So that's going to open up. All right? Good. Write the equation for each function given A and the vertex. All right, so pause the video. Try to copy this model and write the equation of both of these situations. All right, good. So this is going to be y equals A, which is 1, times, it's going to be x plus 2 squared minus 7. All right, the reason it's plus 2 is because it's x minus h. So if I do x minus negative 2, it's x plus 2 because subtracting a negative is adding. Don't forget the square. The square is what makes this quadratic. Remember, you have to have x squared somewhere in your equation to have a quadratic. And the k value is just whatever it is. So plus negative 7 on the end, we would just say minus 7. Here's a little trick. The h value is always the opposite sign of what it is. And the k value is always just what it looks like. So negative 2 comes in as plus 2, negative 7 stays what it is. All right, the next one would be y equals negative 2. That's my a value. X minus 4 squared. And I could put plus 0. This is totally unnecessary, that plus 0. I probably wouldn't even put it. I would probably just write negative 2 times x minus 4 squared and be done with it. All right? All right, now let's go the other way real quick. If I have this equation, how do I know this is a quadratic? Well, it's being squared. X is going to be squared, so I know this is a parabola. Now, what form is this in? Oh, this is in vertex form. Since it's in vertex form, guess what I can find very quickly? You got it, the vertex. So, all you have to do is take the opposite of that, which is 7, and the same as that, which is negative 4. So the vertex, remember HK from our kind of general form. And then the vertex here is negative 4, comma 6. Opposite of that number, same as that number. That 3 on the outside, that does nothing to affect the vertex. Remember, this number on the outside just makes it more wide or more narrow. And if it has a negative, it just makes it open down, which we learned the other day. All right. Last page. What if I'm given a picture? Can I write this in vertex form? Well, if I want to write it in vertex form, guess what I need to find? You got it, the vertex. All right, so what is the vertex here? It looks like it's at 2, comma 1. I can see that right there. So what I'm going to do is I'm going to write it out in vertex form. All right, now the value of a will be 1. When we have you write it out, we're only going to give you a as 1 for now because we're not going to make it wider or more narrow for you. For these ones, we'll just keep your life simple and make it a equals 1 for now. All right, so here we go. We have y equals, and now remember the form is the a value times x minus h squared and then plus k. So this is h, this is k. This is a. So it's going to be y equals x minus 2 squared plus 1. And you're done. Now, again, the same question. Could you double distribute this? X squared minus 2, x minus 2 squared. Do that double distributing, add 1, collect like terms, put it in standard form. Of course you could, but why would you do that? It said, write the equation in vertex form. So we're done. We're done. Last question for you. Why can this not be written in factored form? Well, I'll tell you why. What are the roots of this equation? The roots are imaginary, meaning this does not factor. It does not cross the x-axis. It's above the x-axis. So you can't put this one in factored form because we can't clearly identify the roots. But we can see the vertex is 2, 1. So that's going to be our easier method here. And I just keep going back to the analogy with the linear functions. Each of these forms kind of has its purpose. I like this one if I'm looking for intercepts or if I know the intercepts. I like this one if I have the slope and the y-intercept. I like this one if I have a point and the slope. So you might say, when do I use what? Well, often you'll be told when to do what. But if you're not, then just think, what information do I know? Do I know the vertex? Do I know the roots? And then we can go from there and use the one that makes the most sense. All right, here we go. Which of the following equations could describe the function seen in the graph at the right or below? All right, you tell me, what form is this? X plus 2 times x minus 5. This is called factored form. So what are the roots here? Root 1 would be -2. Root 2 would be 5. But what do you notice about this? The roots are both what? Positive. Here's 0. -2 can't be a root. So can this be the equation? Absolutely not. All right, now look at this one. This is in standard form. So I realize that the y-intercept is -1. The y-intercept is -1. This y-intercept is not -1. Also, this opens down. How do I know this opens down? Because the leading a value is negative. So the picture of this would be opening down wherever it is. So that can't be it. All right, this one is in what form? This is in factored form. So when it's in factored form, I quickly find the two roots to be 6 and 10. Could that be 6 and could that be 10? Absolutely. So this one could be, we're going to kind of box that one in. All right, and these last two are in what form? These last two are in vertex form. So the vertex of this one is -5, 4. Now, if you go to -5, 4, you're up here somewhere. Does that vertex look like it's -5, 4? Definitely cannot be, right? Definitely cannot be. Matter of fact, when you go right and down, you're going to get positive, a negative. And that's a positive and a positive for my two roots. So just by looking at this picture, I get a lot of information. So this cannot be it. Now let's look at this last one. The vertex is 8, -6. Remember, opposite of the one inside, same as the one outside. Could this be over 8 down 6? Probably could be, since it's positive and a negative. So it could be this. We can't rule that one out. All right, last little section. Working backwards will create an equation, but remember there are other equations that will have the same set of solutions. We call them equivalent. Any equation written in this form, y equals a parentheses x squared plus x minus 12, where a is a constant, has the same solutions as the same one but without the a value. And again, I told you, anytime there's a GCF and you pull out an a value that is not 1, all it's going to do is it's going to make it wider or more narrow. So to prove that to you, graph this on your calculator, and then in Y2, graph this. So graph these on the same window. Pause the video real quick. Type this into Y1, type this into Y2. And what I want you to see is that these two actually have the same roots. But you're going to notice one difference between them. All right, you're going to notice roots are the same. You can see they cross through the same places on the x-axis, but one of them is going to be skinnier and the other is going to be more narrow. So 3x squared plus 3x minus 36 is more narrow. All right, let's quickly go through our wrap-up. There are 3 forms in which to write an equation. All right, my first one is factored form, or let's do standard form. Standard form is y equals ax squared plus bx plus c. That is helpful to find my y-intercept. It's also helpful to tell me if it's going to turn up or down. We like this form. It's standard. It's nice. The 2 new ones, we have factored. Factored form is going to be the GCF that we pull out a, and then x minus r1 and x minus r2. I like this form because if I can get it in this form, I can quickly identify the roots. Remember, not all quadratics are factorable, so this is not always helpful, only when it is easily factorable. And the last one is called vertex form, and that is my ax minus h squared plus k. And I like this form if I'm looking for the vertex, or if I have the vertex, I can write it in this form. And again, that a value tells me if it's going to be narrow or wide, and tell me if it's going to open up or down. All right? All right, guys. I know that was a long video today, kind of a tricky lesson. Do your best on the practice problems in the Castle Learning, and if you have any questions, please feel free to email, and hopefully that made some sense. If not, go back and kind of watch some of the parts that maybe it was a little confusing, and go from there. All right, be well.